Alright, so now let's solve this very powerful interview favorite problem called min stack. So the task is basically to design a custom stack that supports all the usual operations like push, pop, top, and a special one called getMin, which should give us the minimum element present in the stack at any time, and it should all work in order of one time complexity. So this means even if the stack has 100 or 100,000 elements maybe, we should always get the minimum instantly in order of one time. So for example, if we push 5, then 3, then 7, the minimum is 3, right? And after popping twice, only 5 remains, so minimum will be 5, right? So that's what we have to do in this particular problem. Now let's see how to solve this. Now the key to solving this efficiently is to use two stacks, not one, right? And here's the intuition. First we use the usual stack, let's call it as the main stack. Then we introduce another stack called min stack, and this will track the minimum value at every level of the main stack. So now let's see carefully how the operations actually work. So on the push operation, we push the value into the main stack as usual, and for the min stack, if it is empty or if the new value is less than or equal to the current min, we just push it to the min stack as well. And the min value at any point in time will be given by the value currently at the top of the min stack, right? Now on the pop operation, we pop from the main stack, and if the popped value is the same as the top of the min stack, that is we are essentially popping out the value which is currently minimum in the stack, we will also pop from the min stack too. And in this way, now the top of the min stack will be the new min which is left in the stack after this current pop operation. Now on getMin operation, we just simply return the top of the min stack, right? That is simple and instant. And finally on the top operation, we just return the top of the main stack, right? So this strategy will ensure constant time complexity for all the operations. Now let's maybe walk through one sample run. So the initial state is that both these stacks are empty, right? Now we push 5 into the stack. So we add 5 to both main stack and the min stack because both of them are empty. So the main stack becomes this, it has 5 now, and similarly min stack also has 5 now. Now we push 3 into the stack. So now since 3 is less than the current minimum, which is 5, we push it to both the stacks again, right? So the main stack now becomes 5, 3 and the min stack also becomes 5, 3, right? Now we push 7, right? Now 7 is greater than the current min, which is 3. So we push it to the main stack only, we don't push it to the min stack, right? So the main stack contents now are 5, 3, 7 and the contents of the min stack are 5, 3, right? Now for the getMin operation, we simply return the top of the min stack, right? Currently it is 3, so that's the current minimum which we return. Next we have a pop operation. So we pop 7 out of the stack, which is the top of the stack currently, right? And since it is not equal to the min stack top, that means we are not popping out the current min value, right? So we don't touch the min stack at all. So now the contents of both main stack and the min stack are 5, 3, right? Now we have getMin again. Now still 3 is on the top of the min stack, so we just return that. Then we have pop again. Now we pop 3, and since 3 is equal to the top of the min stack, we just pop from the both main stack and the min stack. So again the contents of both main stack and min stack are 5 now, right? Now again we have a getMin operation, so the top of the min stack is 5 and that's what we return. And this is the final result after performing all the operations in the sequence, right? So that's the step-by-step walkthrough. Now maybe let's implement this in the code. So we begin by defining a class called minStack, right? This class will include all the required operations like push, pop, top and getMin, right? Now the constructor method is defined next. It gets triggered whenever we create an object of the class. Now inside the constructor, we initialize our main stack. This stack will hold the values that are being pushed. Now we also initialize a second stack called minStack. This will help us keep track of the minimum value at every level. Now we define the push method. It takes a value as input and pushes it into the main stack. Now the value is first appended into the main stack as usual, right? Then this condition checks whether min stack is currently empty or if the new value is less than or equal to the top of the min stack currently. And if yes, it means that this is the new minimum. So in that case, we push the value to the min stack as well. And this way the min stack will always hold the current minimum. Now we define the pop method. This is used to remove the top element from the stack. So we pop from the main stack and store the value temporarily. Then we check if this value is equal to the current top of the min stack or not. And if yes, that means we are actually removing the current minimum. So we also pop from the min stack to keep it in sync with the main stack, right? Now here we define the top method. It simply returns the top element of the main stack, right? And we access the last element from the main stack without removing it and just return it as the result. Finally, we define the getMin method, and this is the core of the problem. It simply returns the top element from the min stack, which always holds the current minimum in the main stack, right? So that's the entire solution implementation. Now maybe let's talk about the time and the space complexity for this. So the time complexity for all the operations, that is push, pop, top, and getMin, will be order of 1 over here as we have seen, right? And the space complexity will be order of n because we are storing every element in the main stack and also possibly duplicating some values in the min stack as well, right? So because of that, the space complexity will be order of n over here, right? So that's it. Now this is a very common favorite interview problem on stacks, which also clears a lot of foundations if you see, right? So practice it well. And maybe as a challenge, try to implement a version of this solution with just one single stack too, right? And now I will see you in the next problem. Happy coding.